Well, today let's discuss two variable inequalities. Does something come to mind when I say two variable? Well, by the time we're done with this lesson today, you're going to be able to graph two variable inequalities. So let's begin with a little warm-up. Let's solve these inequalities and graph the solution on a number line. So pause the video, work the problems, then come back and check your answer. Well, the first one's easy, right? Just divide both sides by 12 and then simplify. So P is less than or equal to 5/4. This or equal to means that we're going to have a closed circle. And since it's less than 5/4, our line goes to the left. On this one, we're going to subtract 4 from both sides. So at 13, this is an open circle, and T is greater than. On this one, we're going to subtract 5 from both sides, then divide both sides by a -2. What happens when we divide an inequality by a negative? Well, we've got to flip the sign, of course. This is or equal to, so we're going to have a closed circle at -3, and it's going to go less than. Very good job. Key concepts for today's lesson. A linear inequality is an inequality in two variables whose graph is a region of the coordinate plane that is bounded by a line. It'll make more sense when we start going over it. Sounds like a lot of words, but we'll get there. The steps to graph a two-variable inequality. So first of all, you graph the boundary line. Now, just like we had an open circle, if it was just a less than or greater than sign, we're going to have a dashed line. If it's or equal to, the boundary is going to be a solid line. And then we shade in the solution. So we'll talk about that in a little bit. If it's less than, shade below. If it's greater than, shade above. All right. So first of all, let's graph this equation. Well, to graph that inequality, let's graph the equation of the line 3 is equal to 3x minus 1. Because of the or equal to, it is going to be a solid line. And we shade below the boundary line. Now sometimes you think, what's above, what's below? So there's an easy way. If you pick a point, such as, let's pick 0, 1. So if x is 0, y is 1. We'll just pick this point. So if x is 0 and y is 1, we would have 1 is less than or equal to a -1. Is that true? Is 1 less than or equal to a -1? No, it is not true. That's because this is not true, we don't shade in this area. But you can pick any point on this side of the equation. So let's pick 2, 0. So if x is 2 and y is 0, we'd have 5 is greater than or equal to 0. That's true. That's why we shade in this portion. Okay, very good. Let's look at example 2. So first of all, we're going to graph the equation of the line y is equal to 1/2 x plus 3. However, we don't have or equal to. It is a dashed line because that's just a simple inequality greater than. Let's look at the points to pick. How about, let's look at 0, 0. Are we going to shade this side? I like to pick 0, 0 because it makes the math easy in my head. Is 0 greater than a 3? No, it isn't. So we're not going to pick the side of the coordinate plane that is 0, 0 because it does not make this equation true. So we shade the other side, or it is above the boundary line. Very good. You guys are ready to begin the lesson today.